everyone. Welcome to week 4 in 5253 Data Analysis Manager. So, we're moved by now, we're moving past just descriptive statistics and past even diagnostic and into statistical inference. So, last week we got into a little bit with sampling distributions and confidence intervals. So, difference in a Z and a T. But this week, we're going to put those to use with hypothesis tests, which can be a little bit difficult for some students. Now, by default, y'all should have all had this before, but some of you may have been 20 years ago, and some of you may have been in a leveling course that didn't teach you anything. So go through it, as slowly as we can to kind of understand what we're doing. And how we're going to use it. So this week we'll start comparing uh, populations using samples from those populations. So we'll do what we call a one sample t-test or one sample comparison, where we compare a population mean to a benchmark using a sample mean and standard distribution with one sample t-test. And then we'll compare differences between two populations using the sample means and standard and variances from those samples, assuming that they're normally distributed. And then I'll show you how to compare, and those for independent samples. So two different populations that don't have, or two different groups that are not related, other than the fact that it's usually the same continuous dependent variable. So maybe you got the guys and the girls for test score. It's all the same dependent variable, but you get two groups, and you're just comparing the means of each of those large groups. Then we'll get into something called a paired t-test, where the independent samples, those are the between groups. Paired samples are what we call within groups. So that's usually similar to when we got correlation covariance, where we're measuring every line against movement in two different variables using every line against itself, kind of. Well, that's what we're doing here. We're comparing this measure for this observation against measure 2 of this observation. Usually it's a time series where we're measuring time 1 and time 2, or before training and after training, or employee specific employee on machine 1 and machine 2, but it's the same. So we're able to control for any outside variance by only looking at the movement within each observation, or within each group, or within each uh, row. So we're able to control for a lot of outside interference by doing that. So the example with the machine machinist, you got on machine 1 and machine 2. Well, you control for the fact that one employee may just be naturally better than the other, or you may actually get a group of employees that are overall better than the other, and it's not due to the machine. But if you go one versus the other with the same machinist, then you control for any outside variance that could come with that, so you get a truer measure. Problem is, didactic data like that can be hard to get. You can have people drop out of the study before it's through, or whatever. So there's pros and cons. And then we'll look at non-parametric or non-normal distribution, because we'll look at for each type of test, we're going to look at the descriptives. We're going to make sure it fits the assumptions of each test. So each test we're going to run from here on out is going to have a set of assumptions. Usually, most of them normality, hom- uh, homeostaticity for some, which means um, basically the variance all the way through the number line is the same, and you don't have variance curving at an exponential rate at one end and not the other. Um, Homogeneity. Um, Samples pretty much the same all the way through. Homogeneity of variances for some, for a set student t-test, which means group one and group two, the variances are the same, so we can use a pool variance if y'all remember that from undergrad statistics. Here we don't have to calculate it, it's already in there, but if not, we can, you know, we'll use something called Levine's test to let us know. And if we fail that, we just apply the Welch test. That was that long formula that you had to calculate by hand probably at one time or another with an even longer degree of freedom formula. So we'll get to those. And then I'll show you how to do non-parametric. If you fail the normality, there's some tests we can apply, but yeah, you won't be tested on those. I'll just show you. Then we'll move forward next week to comparing multiple groups using variance. That's where we get back to the F test, uh, one-way ANOVA, two-way ANOVA within sample, between samples and or between groups and within groups. So um, then after that, we'll move on to week 6, multiple regression, and then week 7, we'll wrap it up um, with some non-parametric stuff and time series. But y'all have um, your end of term project that week, so we'll get into that later this week. And that's pretty much what we got. So next, I'll pull up the module and do a quick walkthrough for where everything's at, what we're going to do, and where to find it, and what all is expected of you. So in just a minute, we'll swap it over. Okay, so here we go. And in week 4 module, we're going to roll through some of these. Yeah, it looks a lot worse than it is, but there is a lot of stuff we got to go through. So we'll go through our introduction page, what's on there, what we're going to cover, and everything. I'll drop this video, right in there below it. You'll be required to watch it. Our 2 graded discussions, which will have a bit of a different format this week because you're going to have both of them are going to be video discussions. So I'll get to that in a minute. And then our graded assignments, to remind you, week uh, week 2 corrections for the analytical assignment are open, so have those done this week. If you want to make corrections, I'll try to get week 3 done as quickly as possible. Then we'll have 2 graded discussions as always. Our little topic quiz on hypothesis testing, null and alternative, hypothesis, what's an alpha value, what's a p value, things like that. Effect size, beta, t-test versus z, those types of things. Then, the analytical assignment. So walk through all of these. First, let's go ahead and open our introduction page, which is where you should start anyway. Again, question and answers up here. You need to go to it, or you can get to it from your start here or from the discussions tab. You can see that. So this week, like I said, we're going to move forward from sampling distribution and confidence intervals to being able to apply them to determine differences in populations using samples of those populations. So we'll be able to infer a population mean based on sample and standard deviation or variance, and we'll use those things to compare different groups of the same, continuous dependent variable. And then when we're doing that, we're going to set everything up. We're going to look at the descriptives and see, and just like we did all the way up to this point, you got to make sure everything is entered correctly. Everything, all your continuous variables entered as scale, all discretes or scale, all your qualitative or either nominative or ordinal, depending on what they are, and check for missing variables, treatment for missing variables, check for outliers, treatment for outliers, all of that, everything that we've done to this far, you still have to do. It gets us to the point that we can use this stuff and apply it. Now, as far as outliers, some of these tests, for every statistical test, you're going to have a list of assumptions, or you can also view those as limitations to that test. So a z-test has limitations. One big one, you have to know the population parameters. You have to know the population standard deviation. If you don't, then you use a t. Simple as that. T-test, normality, homogeneity or variances if you're going to use a studentized t. If not, if you got a normal distribution based on Shapiro, then but your variances are different, then instead of a student, we'll use a Welch. It's just a click of a button in JASP, so it's not long, drawn out, hand calculations this time around. So you just have to know which one to use. Um, if it's not normal, um, then there's other tests. So for the simple t-test, if not normal, you do a Mann-Whitley U. For independent samples, for paired samples, I got a paired t. Um, one big assumption for a t-test is it has to be independent samples. In other words, you don't have the same participants in group one as you do group two. Whereas paired, they are paired in some way. Something's the same, so you're comparing two different measurements on the same row for the same dependent variable. Usually, like I said, this time one and time two. Sometimes it'll be machine one, machine two, or training one, training two, or before training, after training. Or maybe you got a group of stores and you want to know if you're a regional manager for stores, but all your stores are like different sizes, but you want to know if sales are better over the weekends versus the weekdays. Um, then you do a paired sample, and you'd group for store one, you'd group sales per day for this number of days versus the weekend days. That way, you're looking at differences in days and not differences in stores. You're controlling for that. So that's the difference in a within group sample or a paired sample, a paired T. And for a paired T, if you don't have normality, then we got Wilcox and sign rank. Which, those, like I said, you can automatically know on anything I'm testing you that it's not going to be non-normal because it's not a non-parametric class. I'm just showing you what to do if you have it. So for your homework, your analytical assignment, don't pick those two because I don't think I'm going to require you to perform those. If I do, I'll tell you. Mainly, you're going to be picking between one sample T, a two sample student, a two sample Welch. And we're going to get into effect size, which we have to hand calculate in Excel. It won't do. So we'll be able to calculate those and easily calculate confidence intervals and specific, location points, and we'll go over all that. So these are your specific learning objectives. So one sample T, two sample T, using independent, two sample T using paired, uh, knowing what the assumptions are and whether you've met the assumptions of the method and which one to choose based on that. So there are some videos here. These are old videos that go with that Excel macro sheet that's up here if you didn't download it this week. So sometimes you can follow along with that and kind of understand the theory better if you want. I do understand that some of those videos are pretty old and getting pretty grainy. I got to replace those as soon as possible. Um, but again, it's stuff you've already had, so we're mainly applying it into JASP in this course. So here's your book chapters for Vero. Now, chapter 9, that's going to be end of the course. We're not going to do chi-square right now. We're just going to stick to t-tests because they're easier. So normal distributions. Um, if you want to follow along with the examples in the Vero book, I didn't think the chapters in that book were that great. They're hard to follow in the newer version because they don't give you which of these files are using. You got to go all the way to the end of the chapter to figure out which example they've been using. So if I have time, I'll put up video for them. Right now, I do have videos from the old book, which it's going to be basically the same except for the page numbers for Navarro and the same exact same data files to follow with that. This is your step-by-step how-to in JASP. I've got videos in the module that show you exactly how. Oh, actually, no, I have one video in the module that has all three of them zipped together. So individual ones, in case you don't want to go through that. Yeah, I can probably you can just go to my YouTube page and find them, or just go to the one that's zipped together and skip chapters. So example results template. This PowerPoint. If you don't get any other, some of these are useful. Some of them are just not. I didn't think. Some of them are for like statistics of doom. Some of them go with this. I mean, they're just things I grab. Uh, document processing. Shouldn't be. So that's not working. Okay, there we go. So this is kind of a for comparison of means and variances. This is a little thing I put together. It's based on the last year's book, but the students could use for their projects. It'll teach you. Here's a list of effect sizes for all different types of methods, and what you would use for which one, and the range, and how you interpret them. Comparing two population means with independent samples. For parametric, you got independent t-test, studentized and Welch. Non-parametric, Mann-Whitley, like I said. So here's the decision points for each one. Oh, also, I did not put in there, I'll show you in a minute, but the very back of that JASP handbook, there is a flow chart, if you will, for each one of these. How to write up the results right here. Reporting the results for Mann-Whitney, reporting the results for t-test, whether it be a studentized or Welch. So make sure you download this. I'll probably try to go ahead and add it to the module so you don't miss it too. I'll do that while I'm on here when we get back. So two population means using match pairs, repeated measures. So you got a paired t-test and a Wilcoxon sign rank for normal. So we're not using, we're not comparing homogeneity of variances because we're using the same respondents. So you don't have to, there's no assumption there. Cool, so, and here's your different effect size, everything, and here's how you write it up. Constant sign rank, how you write that up. The difference is for non-normal, we use median instead of mean. And the actual, test values are different. Three or more. Here's ANOVA. So we got one-way ANOVA. Between subjects or between groups. So that's next week's. Then repeated measures. So that's, comparison of means and variances here and how to write them up. And then that only leaves multiple regression. So there's some other one of those. PowerPoint. So if they're useful to you, go ahead and download them and use them. If you'd rather just follow along in the book and videos, then that's fine too. Okay, so here's your graded assignments. What else we got here as far as tools? Here's those distribution tables. Nobody's going to be doing it through tables, I wouldn't imagine. Like I said, here's that Excel spreadsheet with all the macros. So if you want to do one sample, two sample, and confidence intervals in those, that's fine. And that's as far as it goes. There's the Excel formulas if you want them, and the Jagged formula sheets. It shows you the Welch formulas for t-test and degrees of freedom, and the studentized t-test and pool variance. And how to calculate degrees of freedom. So if you want to do it by hand, that's how, but JASP does it for you. And it graphs it much better. So, and we talked about finish the week 2 analytic assignment. If you still got that outstanding, if you want to, if you made a 95, you don't think it's worth your time, I'm not going to fault you for it. But if you're scared those points will bite you down the road, knock it out. If you made below a B, there's no reason for you not to. So general discussion topic, p-hacking, we'll get into that in a minute, and our current topic, where we shift from corporate fraud to academic fraud, and it gets pretty interesting from here on out. Hypothesis testing quiz and week 4 analytics quiz. And I told y'all there will be, let's say by the end of the day tomorrow, I'll have some information on what we're going to do for our term project, or and then you'll have a final project at the end. So I want to take a look at what y'all did on week 3 assignments and discussion boards before I make a final decision, but I got a pretty good idea of what we're going to do. So it's nothing to lose sleep over. Just wait till I send out the information and you'll see. It's nothing that's going to kill you. So let's get back to module 4. And here we go. So our graded discussions. So start out with the general discussion video. So we're going to look at a topic called p-hacking, and it tells you got to watch. Now, instead of having you answer the corny little questions and submit at the end, it's just going to supposedly, and I'm just trying to find ways to make these videos not hang up on you or give you dead links. Supposedly, it's just going to grade you on whether you watched the whole video or not. And if you did, it's going to mark it as done, and you'll have to do them all before you can move forward to the next week, as always. So if you still haven't finished everything in week 3, you won't be able to get to week 4 until Tuesday. So Just know that. So this one, we're going to watch a video. Actually, it's three videos strung together, zipped together into one. But they're only like 10 minutes each, and they all talk about this topic of p hacking. Since we're getting into hypothesis testing and p values and alpha values and all that, and effect sizes and statistical significance, this is kind of how unethical ways of achieving the results you're looking for rather than just letting the data show. So you'll watch the video, and since you got basically 30 to 40 minutes worth of video to watch, you're not required to look up any peer-reviewed sources for this general discussion as you normally would. So just the only thing I ask, you actually watch it, learn something, and the answers you provide need to come from out of those videos. Don't just go Google the first thing you see and clip it in and not learn anything. So make sure you're paying attention enough. So the questions on those, what define p hacking and explain why it's bad, and I think list a few ways that scientists could like engage in that type of behavior. So uh, you'll want to double check with it, uh, maybe, but to make sure that's what it is. Let's see, but I think so. And then you'll come down and see several ways researchers may be guilty and how readers might identify or detect some unethical data mining to get p equals zero 0.05, which is an arbitrary number anyway. Um, so make your post, make sure it's something you learn from watching the videos. One is Pete Judo, which you're going to watch several videos of his, are pretty interesting. And then a Stat Quest, which is, the guy's interesting to say the least. And then I finish it up with Statistics Crash Course on the same topics. And she's pretty good, straightforward, and fast moving. So you watch those, and you should be able to answer this. And mainly, I'm looking to make sure you give me an honest answer and you've learned something. Y'all have done very good on these so far, so I'm proud of you. So I want to make sure you learn something, not that you have the perfect answer. So you don't have to go looking up trying to find the perfect answer, or I absolutely don't want you just going and looking up an answer and not even reading it and pasting it in there. That's so as long as I don't see that, we'll be good. Then we'll move forward to our current topic, and we'll see an academic career in the Ivy Leagues get destroyed over p hacking, and that's another judo. Um, and we're talking about a 20, 30-minute video that goes through a lot of things and describes what this guy did, and he was a big name at Cornell. I mean, he was over the largest consumer uh, lab, research lab, especially since it dealt with food service, basically in the world. And he was huge in research circles and lost it all. So we'll go through several of these. This is probably the most minor infraction. So watch it, see what he did. Uh, what you think he could have done differently? Do you think it was that bad or bad enough to lose everything or to get 40 retractions or whatever? So just give me your honest opinion and respond to two people by the end of the week. So you don't have to look up no library research on these, unless you just really need to define something to understand a topic better. Go ahead and turn those on. Come down to our graded assignments, and you don't have to do these first or anything. You just have to watch those videos, and then and participate in the discussion board for you to be able to move forward. So here's all those PowerPoints, but to be honest with you, kind of in a way, and the one you need I don't have in here. So let's go ahead and put it in. Uh, File. See if I can find it. Oh Lord. Here we go. So this is the little template for how to choose the correct test and how to write it up. We don't want to keep that one right there. Or actually, let's pull this one down. Pull this one down next to the JASP. Now here, like I said, here, go through those. I got the old videos here. Any PowerPoints you think be helpful. You got your textbook chapters in the intro page embedded. Uh, really, all these are embedded, so could take them out and make it shorter. But, and then you got a little quiz on hypothesis testing. Then I've got this embedded as have to watch. Although I may change that because that's actually last year's video. It's just I can't get the new one processed and up yet, so that may change because you can't skip chapter or uh, as you move forward, just requirement may change. But the video is basically going to be the same, and you can walk through each of those examples from the book. I worked through them, and the CSV files for these are embedded. So we're on time. Then we got our analytical assignment once you feel pretty confident here. So if anybody's wondering, this other video, that was the original video I had in there, and it's giving me a dead link because it's just YouTube. It wants me loaded into YouTube, but I'm not sure y'all can use the chapters and skip forward in YouTube, which that was the whole point of zipping it together, where you could easily find everything and skip to the chapter you wanted. You can always go to once you watch this, and again, I have it set that way just to make sure it works and to make sure nobody can say, well, I didn't see it. Um, Once you watch that, if you want to go straight to my YouTube video and go find this, then you can skip forward to the chapters, or you can probably find individual pieces in there. And we got our analytical assignment. All right, so click on this analytical assignment. I'll go through it really quickly, hopefully. It's about the third time I've gone through it because I don't know, it keeps losing connection. So these, I will actually, I'm just basically going to go through really quickly. Uh, the first one, if you download like the document, it'll give you a visual of, you can actually just, I don't know what this G is in there for, but you got an ID number, a group number, a group, and a degree of reading power, DRP. So that's your outcome or your dependent variable, your groups, your treatment, and your control. So we're trying to see if basically we had these specific reading classes to increase reading performance. So one group got the classes, one didn't. Basically, how it works. So the ones that didn't, that's your control or your placebo, or whatever, and then the treatment. So we're trying to see if those two groups are significantly different, so we can tell if the thing actually works. So let's pull up the uh, file, and I'll show you directed reading activities here. So like I said, here's your ID. When you load that into JAS, you'll set that as to nominal just to keep it so you'll know what it is, but you don't include it in any frequencies descriptives Because I mean, it's just your primary key. It's just an identifier. It's just your respondent number. Doesn't tell you anything other than what row it's on. Uh, your group, you got your treatment and your control. So again, these people got the classes, these didn't, and then your reading power. So how well you read, compared to the ones that didn't get the classes, how well they read. So we're comparing those two. Uh, Pretty easy. And then what you're going to want to know, you're going to go through here your W statistic for superior will, that tells you whether or not it's normal or not. Your F statistic for Levine's, that tells you whether or not your variance are equal. Once you got those two things, you can tell if we got fairly normal distribution and our QQ plot show home uh, homeoscedasticity. In other words, variance is fairly the same throughout, not peaked on one end, yet not the other, or not curled. Um, then we can use a t-test because we got normal. As long as we do have independent samples, and we do, and the F statistic will tell whether we can use the student or whether we have to use the Welch correction. You'll know that once you go through, the examples in the book. Test statistic, uh, most likely if I'm asking for both of these, then if I'm asking for leans, it's probably a T, uh, and not a man Whitney. Uh, Mean difference, so that there's a button on there, calculates the distance. That's mean 1 minus 2. Based on the results, so you're going to make your assessment of whether or not you got statistically different results and in the right direction, hopefully. Um, have to look at that. I think I asked you on here to determine the significant difference and to determine if it was successful. So I can't remember what the answer is asking for, to be honest with you. I would say one tail greater than, but it may just be asking for a two tail. I'll probably give credit for either one of those since I'm ambiguous. Uh, so you'll do all those and then export to PDF and then upload into two, like last time, and I'll check to make sure you did, from what I can tell, everything correctly. Uh, Give you a grade based on that. Usually for those, as long as you gave me what I asked for and made an attempt to get it, if you did something wrong, I generally just give you like half credit, but it's hard to split 25, so it ends up being 15 instead of 10 because I'm a pushover. That's the rubric on that. Um, if you screwed up real bad but tried, made an honest try, usually I give you 10. Those are pretty much my decision points. As long as y'all don't force me to come up with a fair rubric, which would actually cost you points because I'd have to judge you harder. Stick with it. Same type of deal on the second one. We got eye movement. This one's basically whether you got fixed eye gaze as you're reading down the screen, like if you're speed reading and you're using peripheral vision going down, and you're measuring recall against those that are moving back and forth. Um, for reading recall, and you're determining if one is significantly different than the other one, and you're going to use Levine's test to tell whether or not students or Welch. I guess we're automatically assuming normality, maybe. I don't know. Uh, Test statistic, degrees of freedom for the test statistic, and mean difference and the effect size, which Cohen's D for some, and I'll show y'all in the examples how to perform and interpret that. So uh, then you export your results to PDF. Hopefully y'all got that down pat and upload it here. So that is really easy compared to, especially compared to the last couple of weeks where you've had to actually do a lot. But um, should be able to blow through that one really quickly. And hopefully I can get this part uploaded again without bogging the system down. Uh, so again, as we go through, I'm going to try to weed some of this mess out over the week and maybe combine some of those videos into some shorter, more streamlined current if I have time. If not, you got everything you need. Just got to pick through a lot of things. So anything I can give you more information, if I have time to do it, I will. Um, and I do again want to look at your performance on week 3 assignments and discussion boards to make a final assessment of what we're going to do for our term project, which won't be anything. It won't be anything that just determines whether or not you get your degree. I promise. It's nothing. I'll walk you through it step by step. It'll be able to pull it out, do something of your own, or nothing will be due this week because I don't have it ready Monday. So when the module opens, so uh, if not by the end of the day Tuesday, then definitely sometime Wednesday you'll have some information on my final decision on what we're going to do, and I've got like several to pick from that I usually put together. It just depends on what I think y'all need and where you are as to how we approach it. So don't lose any sleep over it yet, and I'll send out an announcement of where to find the information as soon as I have it ready and out for you. So other than that, y'all be good and contact me in question answer boards if you need help with any of these. So